In this video, I'm going to show you how to model this pulley as shown in exercise 2 problem D. So reading the problem statement, we have that the bushing should be modeled as a secondary body from the base part. So this model consists of a steel pulley with a brass insert as the bushing for the bearing surface. So let's start this off by opening up a new Solidworks part file. And looking at this, I hope you want to recognize that this is going to be a revolve feature because it's cylindrical and it has an axis of symmetry going down the center of the part. So you can model this with extrudes, but it's going to be pretty difficult. Modeling this with a revolve is going to be the easiest and most efficient way to model this part. So I'm going to select a plane. Arbitrarily, I'm going to choose my right plane, sketch, sketch. I'm going to draw a center line representing my axis that I'm going to revolve my sketch about. I'm going to draw a quick rectangle, and this is a little trick that I sometimes use. I'll draw a center line from the midpoint of this bottom line down to my origin, and if I make this line vertical, now I know that this is constrained to my origin in that fashion. So the next thing is the width of this is 1, and let's now select the diameter. The outside diameter of my part is 6 inches. So notice if I dimension from a solid line down to a center line, and if I drag my mouse below that center line, the dimension doubles. So this is SolidWorks recognizing that you're attempting to create a revolve and you want to input a diameter. So my sketch is fully defined, but I want to build in that pulley race into the top here. So I'm going to draw a circle centered at the midpoint there, and I'm going to get my power trim, and I'm going to cut those two locations, and then let's put a dimension on this. This is a 0.375 dimension, and this is kind of annoying me the way the dimensions are stated, right? So I'm going to go up here to my settings, options, and I'm going to go from document properties from ISO into ANSI, because I think that looks a lot cleaner. It's what I'm used to seeing, so I like the ANSI style. So now this is not fully defined. So how do I fully define it? Well, the first step is I can make the center point of my circle and this coincident, and that's going to align the center point with this top surface to give me that full 180-degree arc. The next step is I need to locate this in the I'd say the Z direction if I'm looking at my triad down here. So I'm going to take this point and this line and make those coincident. Now the sketch is fully defined and I'm ready to do a feature revolve boss base. It's asking for the axis of revolution, and so I can select that center line, and there's my preview, hit the check, and I have my first solid body for this part. I'm going to select this face and I'm going to sketch on that front face. I'm going to sketch a circle. I'm going to go in normal to my view so I can see exactly what I'm looking at here. And one little technique here is I'm going to draw a circle up to the midpoint there, make that circle for construction, and I'm going to put a 3-inch diameter on that construction circle. So this circle essentially constrained the radial location of this hole. So that's a little trick you can do to define that. Let's make this a 1-inch hole, and this should be vertical from this point. Now that's fully defined. One thing you can do now is with construction lines, we can draw a nice little X to make a little orthogonal grid here, and then I can draw circles at every one of these points, and now my center points of my circles are all defined. Next thing I can do is select all 4 circles, make those equal. Now I have a fully defined sketch of 4 closed shapes that I am going to go features, extrude, cut through all. Alright, so the next step here, and this is a little bit easier to visualize if you do a section view, is I'm going to cut a section view on my right plane. If you remember, the right plane was my original sketch plane for my first feature that I did here. So my first sketch was on the right plane, And now my second sketch, I'm going to select right plane. Alright, so I'm still in my sketch. I'm going to draw another rectangle to represent what the bushing is going to look like, and then I'm going to draw another center line that's going to be my axis of revolution. So this bushing has a width of 0.950 and an ID. Again, remember this trick, if you dimension from a center line to a visible line, if you drag it below the center line, it doubles. So that ID is 1, ID is inside diameter, OD, outside diameter, is 1.5. And now this is still not fully defined because it's not linked to my origin. So two different things I could do. I could dimension from here to that edge as 0.025 to fully define it. Or the other trick that I showed you earlier is if you draw a center line from the midpoint down to the origin and you make that center line vertical, that becomes fully constrained and fully defined. Next step is revolve boss base. Axis of revolution is this center line, and that preview looks good, but one thing to notice, if I remember from my problem statement, is that the bushing should be modeled as a second body. So this merge result button right here, if I click that and I accept, you see that this is all one body. It added that material in a way that joined the bushing and the base material for the pulley as one. If I go back and edit that feature, I can uncheck merge result, and then it treats it as a secondary body. So you see there's a visible line there representing the change of body. So after you model that, double check that all your sketches are fully defined. There's no minus sign. Minus sign means minus points. Undo my section view, and there is my finished product. Thank you for watching.